Imagine a machine so powerful it can reach the edge of space, travel faster than 7,000 kilometers per hour, carry hundreds of tons of fuel, and survive temperatures hotter than molten lava for over 60 years. Every rocket ended the same way: launch, mission complete, then crash into the ocean or burn in the atmosphere. Billions of dollars destroyed after just one flight. It was considered normal until one company asked a simple question: what if a rocket didn't have to die? What if it could turn around, fly back, and land perfectly upright as if it were an airplane? Today, that impossible dream has become reality. SpaceX rockets don't just return to Earth. Some of them are caught in midair by two giant steel arms, without a runway, without a pilot, without touching the ground. It looks almost impossible, a rocket falling from the edge of space, stopping within centimeters. How does it know exactly where to go? How do its engines restart after leaving space? How can computers control thousands of tons of metal with incredible precision? And why do experts believe this technology could completely change the future of space travel? The answer is one of the greatest engineering achievements in human history, a combination of powerful engines, artificial intelligence, precision guidance, and years of relentless innovation. Today, we are going inside the incredible engineering behind SpaceX's reusable rockets to discover how they return, how they're caught, and why this breakthrough may open a new era of space exploration. Before SpaceX changed everything, every rocket had the same fate: launch, reach space, complete its mission, then be destroyed. The largest part of the rocket is called a first stage booster. Its job is simple: lift enormous rocket through Earth's thick atmosphere using millions of kilograms of thrust. But after just a few minutes, its fuel runs out, the booster separates and begins falling back to Earth. For decades, there was no way to save it. Some boosters burned in the atmosphere, others crashed into the ocean, never to be used again. Imagine buying a brand new passenger airplane, flying it only once, then throwing it away. That's exactly how the space industry worked. Every launch required a completely new rocket, new engines, new fuel tanks, new components, making space travel extremely expensive. Engineers knew the biggest problem wasn't getting to space, it was throwing away the most expensive part. After every mission, then, SpaceX introduced a revolutionary idea: don't build a new rocket every time, bring the old one back, refuel it, inspect it, and launch it again, just like an airplane. Sounded impossible because recovering a rocket is far more difficult than launching one. A falling booster must survive extreme heat, violent winds, supersonic speeds, then restart its engines, steer itself back home, and stop with incredible precision. Most experts believed it couldn't be done. SpaceX set out to prove them wrong. The moment the booster separates, its journey is only half over. Instead of falling out of control, the rocket forms an incredible maneuver. It flips completely in midair. Imagine a skyscraper turning around while falling. That's essentially what happens. But how? The engines are off. There are no wings, no pilot. The answer is hidden near the top of the booster. Small devices called cold gas thrusters. These tiny nozzles release high-pressure gas, creating small pushes, one after another, slowly rotating the entire rocket until it points back toward Earth. Every movement controlled by onboard computers. They receive constant data from GPS, inertial sensors, gyroscopes, and accelerometers. Dozens of calculations are made every second. The rocket always knows its position, its speed, its angle, and exactly where it must go. Once the booster faces the correct direction, three engines suddenly restart. This is called the boost back burn. The engines fire for only a short time, but it's enough to completely change the rocket's path. Instead of continuing toward the ocean, the booster begins flying back toward the launch site. From this moment, it is no longer a falling rocket. It becomes a guided vehicle, carefully steering itself home using nothing but powerful computers, precision engineering, and physics. As the booster falls back toward Earth, it faces a new challenge: control. At this speed, the rocket is traveling faster than the speed of sound, the air becomes a powerful force pushing against the booster. From every direction without control, the rocket would spin, lose balance, and crash. That's where four incredible devices take over. They are called grid fins, mounted near the top of the booster. They don't look like airplane wings. Instead, they resemble strong steel grids. As the rocket rushes through the atmosphere, air flows through these grid fins. By moving only a few degrees, the fins can change the rocket's direction. Left, right, forward, or backward, just like tiny adjustments on a steering wheel. But at supersonic speeds, every movement must be affect too much, and the rocket could lose control. Too little, and it would miss the landing point. Every second, the onboard computer receives thousands of measurements: wind speed, air pressure, rocket angle, altitude, velocity. It instantly calculates a perfect position for each grid fin, making hundreds of tiny corrections every second. From the ground, the booster looks calm, almost effortless, but in reality, it is constantly adjusting, correcting, and steering until it lines up exactly with its target, preparing for the most difficult part of the entire mission, the landing. Now comes the most dangerous moment. The booster is still falling toward Earth at incredible speed. If nothing changes, it would strike the ground with unstoppable force. So how does it stop? The answer is something almost unbelievable. The rocket uses its own engines to slow itself down just seconds before landing. The onboard computer commands the engines to restart again. This is called the landing burn. Unlike a powerful launch where dozens of engines produce maximum thrust, now only a few carefully controlled engines ignite. Their job isn't to lift the rocket, it's to fight gravity. Every second, the engines reduce the booster's speed from hundreds of kilometers per hour to almost zero. At the same time, the computer continuously adjusts the engine power. Too much thrust, and the rocket would rise again. Too little, and it would crash. Thousands of calculations are performed every second, measuring altitude, speed, wind, fuel, and engine performance. The rocket is constantly correcting itself until it reaches the landing point, almost motionless, standing perfectly upright. It isn't just slowing down, it's balancing a giant tower of steel on a column of fire with extraordinary precision. One tiny mistake could mean mission over, but when everything works, the impossible becomes reality. A rocket returns from space and lands as gently as an elevator. Landing on the ground was already an engineering miracle, but SpaceX wanted something even better. Instead of landing on massive legs, what if the rocket could be caught before it even touched the ground? That's exactly what the company built: a gigantic launch tower standing over 140 meters tall. Attached to the tower are two enormous mechanical arms. Engineers nicknamed them the chopsticks. Their job sounds impossible: catch a falling rocket at precisely the right moment. As the booster approaches the launch tower, its computers are no longer just aiming for the ground, they're aiming for a tiny target only a few centimeters wide. The rocket communicates with the launch system, constantly updating its position, its speed, and its direction. At the same time, powerful sensors inside the tower track every movement, waiting for the perfect moment. Then the chopsticks move inward, grabbing special reinforced catch points built into the booster. The engines shut down. The full weight of the rocket transfers to the giant arms in just a few seconds. A machine that had reached the edge of space is hanging safely on the launch tower, ready to be inspected, refueled, and prepared for another mission. No crane, no recovery ship, no long delays, just extraordinary engineering system designed to make reusable rockets faster, cheaper, and more efficient than ever before. So how does SpaceX catch a rocket? The answer isn't one invention, it's thousands of engineering ideas working together. Powerful engines lift the rocket into space, cold gas thrusters turn it around, grid fins guide it through the atmosphere, onboard computers make thousands of calculations every second. The landing burn slows booster with incredible precision, and finally, the giant chopsticks. Hatchet without touching the ground for decades, rockets were treated as disposable machines built to fly once, then thrown away. SpaceX changed that idea today. A rocket can launch, return, be inspected, refueled, and fly again, just like an airplane. That single breakthrough could reduce the cost of space travel, make future missions more frequent, and bring humanity closer to building permanent bases on the moon and one day Mars. What once looked like science fiction is now real engineering. Every successful catch brings us one step closer to a future where space travel is no longer extraordinary but ordinary. If you enjoyed this documentary, don't forget to like, share, and subscribe to *RailForge***, because here we explore the incredible engineering behind the world's greatest machines, mega structures, modern technology, and the innovations shaping our future. Thanks for watching, and we'll see you in the next documentary.